L2 regularization is a common method that we have been seeing so far. Basically, it penalizes large weights. Dropout is another, and which is the most popular regularization technique for deep neural networks. It is used to prevent overfitting, basically by dropping nodes, also connections during training. Each node is retained with a fixed probability p, or dropped with the probability 1 minus p. So here p is the hyperparameter to be chosen. Drop connect is a general version of dropout. Basically, each connection can be dropped with a probability 1 minus p. Each neuron receives inputs from a random subset of neurons in the previous layer, and it introduces dynamic sparsity on the weights within the model, and this is different from the dropout method. Early stopping in training uses validation error to decide when to stop training, and basically when some monitor quality has not improved after and subsequent epochs, then stop. What is an autoencoder used for? An autoencoder is used for unsupervised learning, basically without the support of labels. It is a network that learns an efficient coding of the input. Here we have the model, which is trained to predict its own input and mapping it through a representation created by the hidden units of the network. Usually, the number of hidden units is much fewer than the number of inputs or outputs. Let's look at this example. In the training step, the data is passed through the network and compressed at the hidden layer, and later reconstructed at the output layer. After training, if we remove the output layer, what we have left is the compact representation of the inputs provided by the hidden layer. Autoencoders can be stacked on top of each other, and here we call them stacked autoencoders. So let's say if we have this autoencoder. After training, we remove the output layer. What we have left is just this, including the input and the hidden layers. And then we put another layer, another autoencoder on top of it. This is existing layers. And then we put a hidden layer and an output layer on top of it. And after training, we remove the output layer. And what we have left is just this, which is the stacked autoencoder.